Hello, so today's section is 1.4 and this is on inverse of a function. So first of all, if f is a function with domain, so domain, reminder here, represents x values. And range b, so range, reminder, are y values. The inverse function, if it exists, is denoted by f to the minus 1 and has a domain b and range a. So if the function has domain a and range b, so a and b just representing some set of numbers, then the inverse would have domain b and range a. So one thing I just want you to note down, just to be aware here, is that when we're talking about an inverse of a function, this does not mean the same as the reciprocal of a function, okay? So two different things. All right, moving on. So the inverse maps y to x if and only if f maps x to y. So what this is really just trying to say here is that the x and y values will flop. So when we're looking at mapping, the original is x and y. When you look at the inverse, those values will now change y to x. So for example, if your original graph had the point 3, 4, when you take the inverse, it's now 4, 3. So before we continue, let's just quickly look at what a function is. So a function is a relation such that for each value of the domain, so for each x value, there's only one corresponding y value. So if there's more than one y value for that x value, then that's no longer a function. So looking at these two examples below, when you're looking at a graph and you would want to determine if it's a function or not, one useful tool that we use is is what we call the vertical line test. Line test. And what that is if you just draw straight vertical lines on your graph, as long as you're only crossing one point, then yes, we are looking at a function. But if you draw a straight line down and you see, I'm crossing 2 points, or even more sometimes, then this is no. Okay? So that's the difference between yes, a function, and no, not a function. So let's look at an example now. So right now below here, we have a graph and we need to graph the inverse. So here, with this graph here, first we want to start by picking out our key points so we can actually figure out the inverse. So here are my 5. So I'm going to be writing in green just because the graph's already blue. So remember, our original points xy will now become yx. So the key points here we have are -5, 2, 0, 0, 3, 5, 6, 0, and 8, 5. Oh, sorry, that's 3, 4. Saw the wrong one there. Okay. So for the inverse, we just need to flip the numbers around. So instead of -5, 2 is just 2, -5. 0, 0, nothing changed there. So now it's going to be 4, 3, 0, 6, 5, 8. So now we have our points. Let's put them on the graph. So 2, -5 is down here. 0, 0 is at the origin. 4, 3 is up here. 0, 6 is up here. Up here. And 5, 8. 5, 8 is up there. So So now that we have all our points, let's just join them together. You know what? Let's, oops, I thought I used the straight line function. Yeah, I did. Okay. Let's actually be fancy and use this and try to draw a straight line. Okay, we got that one. Let's try to draw another one. So there, from here. Oops, this point didn't quite make it. Okay, there we go. And oh, that didn't want to do it. Ah, there we go. And here, let's move that one back down there. And one more. Oh, bear with me. Okay, and let's move that one down. Not bad. Okay, so here are our lines. And what are we supposed to do next? Ah, yes. So state the domain and range and intercepts for the relation and the inverse relation. Okay, so first, let's write down B. So the domain and range, so when we talk about the relation here, this is basically just talking about that original function. You could think of it as f of x. In this case, that's that blue graph. Whereas the inverse relation is that f negative 1x, okay? So domain, let's looking at our f of x first. When we're looking at the domain, so all the possible x values, we're going from -5, so all the way on this side here, from -5 up to here, which is 8. So it goes from -5 up to 8. And then the range, which are the possible y values, go from as high as this value here. So it goes up to 5. And then the lowest y value is on the axis, so that's 0. Or sorry, that's 0, yes. Okay. As for the inverse, well, we know for the inverse, you're always just switching x and y. And domain and range is related to x and y. So it only makes sense that, well, you'll just flip them. So what was the domain in the function is now going to be the range in the inverse. So it'll go from 8 to -5. So these two will just match. And what was the range in the function is now the domain in the inverse, like so. Okay, so that brings us on to C. So state any invariant points. So with this particular graph, if you haven't noticed already, it's actually a reflection, right? But that reflection line, instead of being on the x and y axis, it is actually along this diagonal line, which is the x equals to y axis. So this red line here that I'm drawing is the x equals to y kind of line. And you can see there's actually a reflection there. And the invariant points are always points that lie on the reflection line. Therefore, in this particular case, we have two. So we have this point right here and that point right there. So at these 2 points, we have our invariant points, what I like to short term as IP. Okay, just 2 of them. The ones that lie on the reflection line. Okay, moving on to our next example. So now we're looking at a function that we are so familiar with. It's a parabola with a small transformation. So this too, what is it doing to it? It's a horizontal translation. In what direction? Left to. Okay, so first we're going to graph the function and then determine if the inverse is a function, okay? So if you need to still map it, go for it. I'm just going to map it now because it's simply just moving the parabola 2 to the left, so I know from 0, 0 it's moved 2 over. So I'm just going to graph it like this. You should be getting pretty darn familiar with graphing parabolas now. Okay. All right, so there's our parabola, or our f of x function. Okay, I'm actually going to skip the question, is the inverse a function? And I'm going to come back to it after I do question B, which is to graph this. So once we graph it, it'll be very clear whether or not this is a function or not. So when I graph it, let's point out those key points. So again, I'm just going to show the mapping here, which is like that. So the key points I have are -2, 0, -1, 1, -3, 1, -4, 4, 0, 4, and -5, 9, 1, 9. To find our inverse, I'm just gonna flip those two numbers around. Oh, starting to get off alignment here. Okay, oh, back on track. And finally 9, 1, okay. So now that we have all our points, it's a matter of plotting it. I'm gonna plot it in green again. So first point is at 0, -2. And then here at 1, we have 1 and -3. At 4, we're at 0 and -4. And then at 9, we are at 1 and -5. And then connect the dots. Make sure the lines are curved because this is a parabola after all. There we go. Okay. So once we've graphed it, let's go back to question A and determine, is the inverse of f of x a function? Again, to determine if it's a function, use that vertical line test. And when you draw a straight line down the page, I'm crossing more than one point. So, nope. It is not a function, okay? So one thing that you'll actually note is that in order for A, we could have actually figured out if the inverse was a function without having to actually draw it out. And what you would use there is something called, note, something you could do is to use something called a horizontal line test. So I'm just going to write note here. So to determine if if the inverse is a function, then use horizontal line test on the f of x, or the original function. So what that will look like is the following. If you draw a horizontal line test here, oops, and you see, hey, I'm crossing 2 points, then you know that your inverse function will not be a function. Okay, so the horizontal line test is something you test on the original function to determine if the inverse is a function or not. Okay? All right, so moving on to C. So describe how the domain of f of x could be restricted so that the inverse of f of x is a function. So when we're looking at the f of x, or the inverse of the f of x, this green graph here, it's not a function because once you get to the vertex here of the parabola, it's kind of repeated below and above. So as long as we eliminate half of our parabola, then we actually would have a function. So I'm just going to represent it with, I'm just going to highlight it here. So if we only took from the vertex this top part of the parabola, then this would actually pass that vertical line test. So the corresponding part on the original function would be this part right here. Okay, so these are the two parts. Again, you can see that reflection on the x equals to y. If you kind of see that, I'm just going to jot in this reflection line here. You'll see that that part reflected, right? So if we restricted the domain, then it would be okay. So for letter C here, so for this yellow part, if we restricted the original to only have values where x is bigger than -2, so x will need to be bigger than -2, then that would work. I'm just going to highlight this yellow just so we remember. So that means, you might have noticed, if you just restrict the top half of the inverse, therefore we can just restrict the bottom half of the inverse, which would correspond with the left side of the parabola. And therefore, so if x is smaller than -2, x is smaller or equal to -2, then we would be okay as well. Okay, so these are two different ways you could restrict that domain and the inverse would still be a function. So the last part of today is just finding the inverse function algebraically. So yes, you can always just graph it out and then flip all the points, but sometimes if you just want that equation of the inverse function, then this is a way to do it. Oh, so let me just actually make more space here. Oh, oops. There we go. All right, there we go. Now I have space to write. Okay, so our first example here is f of x equals to 3x minus 7. So the first thing you'll do, change the f of x to a y. So it's going to be y equals to 3x minus 7. And then the next step here is you're going to change the x and the y, because that's what you do with an inverse function. The x and the y is going to switch places. So you're going to have x on this side, and you're going to have the y there. Now you're just going to move the y to one side, rearrange it, and isolate the y back by itself. So I'm going to move the 7 over. And then I'm going to divide everything by 3. So y is by itself, so the 3 cancels out. So you're left with, I'm going to move it over here. So you're left with y equals to x plus 7 over 3. Here is the inverse function. All right, looking at our second example. So same thing. Change the f of x to a y. And first, and then we write our function. Now we need to flip the x and the y. So what was x is now y. What was y is now x. And now it's just a matter of rearranging this. Okay, and we're just going to move that 3 over. X plus 3 equals to y plus 4. Now we'll just need to square both sides to get rid of that root. So that's gone. Okay, so we have x plus 3 squared equals to y plus 4. And we will need to now move the 4 to the other side. So we have x plus 3 squared minus 4 equals to y. Okay, and just to write it back in the way that we're used to, let's have that y on the left side. I'm basically just rewriting the same thing. Voila, there it is. And that's it for this section.